Bismillahirrahmanirrahim. So test one circuit and observe X, the number of rejects. So X is a random variable which is the number of rejects. So part A, what is Px of X, the PMF of random variable X, if reject probability is P. Part B, what is Px of X if P is equal to 0.2. So we note that this is a single experiment with two possible outcomes, right? So one test with two outcomes, right? So X, in this case the random variable, has two possible outcomes, right? So this kind of random variable is treated with Bernoulli distribution, right? So we say that X is distributed as Bernoulli random variable, Bernoulli with parameter P, or we can simply shorten this as Bern P. So this is tilde and this is read as X is distributed as Bernoulli random variable with parameter P. So in this case, in the given problem, P is the probability of rejection, right? So however, when we describe Bernoulli distribution, we say that the P is the probability of success. So in this case, in this particular problem, the rejection is a success, right, in the context of Bernoulli distribution. So the PMF of this random variable, the Bernoulli random variable, is given by this is the probability is P when we have a success, when X is equal to 1, when we have a reject. So when we have a reject, we treat it, we represent it as X is equal to 1, and when it is accepted, the probability is 1 minus P, not P, 1 minus P, right? 1 minus P, and in that case X is equal to 0, and this is 0 otherwise, right? So when it is a reject, we represented X is equal to 1 and the probability is P, and when it is acceptable, it is represented using X is equal to 0 and the probability is obviously 1 minus P, and the probability is 0 for all other values of X. So this is part A. So part B, here we are given that P is 0.2. So simply the probability of rejection is 0.2, so obviously the probability of acceptance will be 0.8, right? So we can substitute the value of 0.2 here and find out the PMF, right? So in that case, the PMF is, this is 0.2 when X is equal to 1, and this is 0.8 when X is equal to 0, and this is 0 otherwise, right? And we can represent it using a simple bar chart also. For example, along this axis we have X, and we have, for example, a 0 here and a 1 here. X is equal to 0 and X is equal to 1. At X is equal to 0, this is 0.8, and X is equal to 1, this is 0.2. So suppose this is 0.2 right here, then 0.8 is somewhere 2 to 4 to 6 to 8 here, right? So this is suppose 0.8. So this is 0.8 at this level, and this is 0.2 at this level. So this is a graphical representation of the PMF of the random variable X.